Hello, everyone, from wherever you're joining us, either good evening, good afternoon, good morning. We'll be starting our IWCS webinar here in just a few minutes. We're giving folks a few minutes to join, and we'll go ahead and get started. We have an excellent webinar for you this morning here in the East Coast of the United States, and we'll start in a minute. While we're waiting, I want to remind you that IWCS is now accepting abstracts for our technical symposium that takes place in September. I'll remind you again during the webinar, but if you haven't done so already, we look forward to seeing an abstract from you or a colleague in your company or perhaps in your supply chain that would be able to present the excellent innovations that you all are accomplishing in our industry. So please visit the IWCS.org website and submit your abstract. It's a fairly easy process. Okay, why don't we go ahead and get started. Again, my name is Dave Choudhury. I'm your IWCS CEO and Director, and I'll be moderating today's webinar. A few housekeeping items. Please note that as an attendee, you're part of a larger audience. So during this presentation, all participants will remain in listen-only mode. And also, please note that this event is being recorded for rebroadcast, so you can watch it again through links from our website. We encourage you to submit written questions at any time during the presentation. Please use the chat panel on the right of your screen. I believe you need to go to the top or the bottom of your screen and select chat. And after typing your questions in the space at the bottom, please hit the send button, and we will address your questions, time permitting, at the end of the presentation. Again, the IWCS webinar series is hosted by the Cable and Connectivity Industry Forum. And today we welcome Mabud Choudhury, who's the Standards Manager for OFS. Mabud has been a consistent and valued contributor to IWCS for many years. Mabud will be presenting his paper today on multimode fiber links for 800 gigabits per second and 1.6 terabytes per second networks. Mabud Choudhury is the Standards Manager for OFS. He contributes to the IEEE 802.3 Ethernet, INCITS T11, the fiber channel, and IEC fiber standards. He is the vice chair for the IEEE P802.3 DB 100 gigabits per second, 200 gigabits per second, and 400 gigabits per second short reach fiber task force. Mabud has a master's degree in mechanical engineering from the Massachusetts Institute of Technology. And he also holds a Bachelor of Science degree in mechanical engineering from Duke University. And he also holds 32 patents, so a real valued contributor to our industry, and I'm sure you'll learn a lot from him this morning. So Mabud, welcome.
Thank you, Dave. Thanks for that introduction. And Dave, I always want to thank IWCS for the job that you do. Michelle, Becky, lots of folks that just do a terrific job for our entire industry. So we appreciate that. And OFS appreciates the opportunity to present this in last October's in-person conference that we had, and now as a webinar. So thank you for that. And as you indicated, my topic is multimode fiber links as we enter the terabit era. So we're up to 1.6 terabytes or developing standards for that. So in terms of our agenda, I'll look at some of the market drivers, why we're going to these higher speeds. A lot of the presentation is through the lens of standards. That's where I spend a lot of my time. So Ethernet standards, there's a new MSA That's a terabit BiDi, and I'll touch on that in terms of multimode links as we're going to those higher data rates. Some of the IEC and TIA standards for NPO type, but also some breakout connectors that are appropriate for parallel multimode PMDs. Then fiber channel, which is an important enterprise level storage area network standard that's been 90% multimode links throughout most of its history. And then sort of multimode fiber, the enduring advantages and conclusions. I do want to start off and say there's lots of great single mode solutions. OFS provides that. The industry does that. So while this is from a multimode perspective, there's obviously lots of excellent single mode solutions that are there also. So network bandwidth explosion, there's lots of different charts on this. This is from Ethernet. Ethernet does a bandwidth assessment periodically. So this is one that looks at growth rates in the network between 2017 and 2025. And there's just simply a huge explosion of data for things like VR and AR, which started from a much smaller base. It's a 55 times growth. So 55-fold increase. And for data centers, the topic that I'll be focusing on, there's a 10x growth. The impact of COVID, we've all learned to live with COVID for the last 3 years. More virtual initially, and those of us who were fortunate to be able to do that, most of my standards meetings became virtual. We've reverted now to more of a hybrid structure, and that's sort of having both options. It's a kind of a common theme throughout this presentation. So IWCS was brave enough to have a conference in a person only. Most conferences and standards meetings are hybrid, and we rely on those data networks to let us do our work and to live our lives on a personal basis. So again, DC traffic growth. This is from an expert affiliated from Google that shows even without machine learning, the tremendous growth that's happened in terms of data center data usage rate. So data center traffic just continues to grow dramatically. And the other big driver, and this is true for the applications we're talking about as we go towards terabit, 800 gig, 1.6 terabyte, but one of the huge drivers is AI and machine learning. There's lots of news currently about ChatGPT. It had 1 million users in 5 days, 100 million in 2 months. So there's lots of interest in AI. And what this curve shows is if you see that there's sort of growth along Moore's law, sort of doubling every couple of years. And then there's this huge kick up that starts happening in 2012 using parallel processing with GPUs, which were originally defined for graphics, but now increasingly used for machine learning. And Google and others have introduced TPUs that do matrix computing, basically allow neural networks and deep learning. That's giving us this sort of natural language interface. And that's enormously driving the need for higher and higher data rates, bandwidth, and speeds. So in terms of the markets that are out there, it's sort of there's been this fundamental cloud transformation that's happened. That left chart is a chart from that shows in revenue the different market segments. And if you look at in the left, a few years back, almost 10 years back, the biggest market was legacy enterprises. So these were on-premises, non-cloud type data centers. And these have steadily gone down, and we expect them to essentially disappear over time. The big growth has been in the public clouds, the largest of the US ones. There's Chinese, but there's still a very large segment that's hybrid, that's private, that's a combination. So there was some forecasts a few years ago that there would be no enterprise data centers. That has not proven to be correct. Those enterprise data centers have transformed to allow cloud computing, and there's a lot of hybrid, again, multiple options that allow people to get their jobs done, including mission critical work that enterprises deal with. The chart on the right is from Light Counting. I actually thank my friends at Light Counting. I'm a big fan of Light Counting. They do a terrific job, both in terms of historical data and as well as projecting out what's happening with optical modules and transceivers. And they revise their updates every 6 months or so. So they keep things current. Life changes. Nobody predicted COVID, for example, 3 years ago. So that change the industry, but light counting always keeps a pulse on that. And so what you're seeing is this, again, these higher and higher speeds, 400 gig becoming stronger and stronger, 200 gig sort of plateaus, and then you've got 800 gig taking off even now, starting now in 2023, and we'll also start seeing 1.6 terabytes. So this is for both all single mode and multi-mode. Later in the presentation, I break out some of the differences there. So for VCSELs, this is sort of a chart I've used for many presentations, historically for short reaches, and that short reach today is largely defined around 100 meters type reach. It used to be longer, up to 500, 550 meters. In the past, with lower data rates, as data rates have gotten higher, that reach has shrunk down to 100 and even less in some instances as we go towards 200. But VCSELs have basically, they're fairly mature technology, very reliable technology that focuses on low cost and low power. From a fiber perspective, because single mode has a larger, multi-mode has a larger core than single mode, it's easier in terms of the connectivity, in terms of terminating to that, and it tends to have a higher resilience to contamination. The policy is always, and protocol is always, to clean and inspect before you terminate a connection. However, multi-mode tends to be more user-friendly from that perspective. And it's been, again, decades of high volume, very reliable connectivity. And for short reaches, it's tended to be the dominant optical link of choice. So another view from VCSELs, this is from some of my friends at Finisar, that's was taken over by II-VI, and then more recently by Coherent, the company, not the technology. But this is showing that just VCSELs overall have gone from millions to billions of, hundreds of millions to even billions of units shipped. A lot of it is now focused on what's in your iPhone or your Android phone in terms of 3D sensing. There's applications in automotive with LiDAR. And so it's just been a huge thing. And the communications VCSELs have continued to be deployed in larger and larger scales of the wafer size have increased, also improving yield and cost. So in terms of Ethernet standards, this captures sort of the evolution of multi-mode Ethernet standards. On the left, it's lane speeds. So starting at 10 gig, and there's lots of 10 gig that's deployed today in enterprise markets, and going up to 25, 50, 100 is a standard. Dave mentioned that I was vice chair for the DB standard. That standard is published, so I'm no longer vice chair because the standard is now complete, and it was successfully introduced on time. So there is a standard for 100 gig lanes. And there's a question, which is part of this webinar and presentation, what happens with 200 gig lanes? So I put a couple of question marks here. There is no active standard looking at 200 gig VCSELs. So 100 gigabaud PAM4, for example, that doesn't appear there, but that's potentially in the horizon. In terms of link speeds, we've gone from increasing speeds to 100, 400 was introduced with the CM standard that I'll talk about. And then we are looking forward to introducing 800 gig in the next couple of years. There's a new standard 802.3p, 802.3df that will introduce multimode at 800 gig speeds. So moving on, this is again the CM standard, so sort of a little bit of historical look, and this is with 50 gig lanes, so 25 gigabaud PAM4 type signaling. This introduced a couple of PMDs. One is SR8, so this was over 8 pair. Most applications in the past, we've had 16 pairs, we've had some sort of niche type things, but the dominant application has been 4 pair and 1 pair in terms of implementation. And so this became an 400G SR8 over 8 pairs. And the initial deployment, which is it's been implemented, it's deployed, it's been quite successful, is it's a 2x200. So that ability to break things up into 200, 100, and even 50 gig lanes was important. This standard also, for the first time for multimode, introduced BiDi, and a wave division multiplexing technology that put 2 wavelengths. And so you had 400G SR 4.2. So you got 400 gig with 50 gig signaling, 2 wavelengths over 4 pairs. and that was published in March 2020. The SR8 has been the more widely deployed standard, but the SR 4.2, which has been slow to being adopted, is now being adopted as we speak. So the standard that I just mentioned, when I presented this back in October, it was the way IEEE works. If you see the P designation before the number, that indicates that it's still an active project. It no longer is, so it's now IEEE 802.3 DB -2022 is the full official name, and that was published December of last year. So it's a very new standard. And what it does is introduces 100, 200, and 400 over 1 pair, 2 pair, and 4 pair. And there's 2 reaches that are here. So what's new relative to some previous standards is that there's a new VR designation for 50-meter reach on OM4 and OM5. And the SR designation continues for the 100-meter reach on OM4 and OM5, and there's shorter reach on OM3. These all operate on a single wavelength, so they're 850 nanometer based transceivers. The initial targeting is basically server storage and accelerator, back to sort of the machine learning and AI that is driving a lot of the market here. The other quick thing I'll mention is that for the 200 gig and 400 gig, which use MPO 12, or sometimes referred to as MPO 8 if you're populating only 4 pairs, same connector. There's 2 interfaces. There's a PC or flat interface that's specified, and there's also an alternative optional APC interface that's specified. The flat tends to be friendlier to a lot of installed base and enterprise markets. The angle gives a higher return loss. It's tied to a higher return loss performance that's preferred in a lot of the cloud computing type applications. So again, this was sort of one of the key use cases. The way IEEE 802.3 works is that you contribute as an individual and you indicate your affiliation. So Zuowei Shen, who's affiliated Google, provided this use case in terms of where things are migrating. And we are going from essentially what was a top of rack to what she identified as a remote top of rack. So what you've got is these links that are longer than what copper can support. So within the rack, if you're dealing with 1, 2, 5 meters, you're fine. These are basically lengths up to 50 meters that were required. And the goal was to have essentially something that had the lowest power, lowest latency, lowest cost structure. So that's what drove the VR type specification. I'm going to jump to a new standard that's current. It's certainly the largest standard, one of the largest standards that IEEE has ever taken on, and in fact recently became split. It started off as P802.3 DF. It's now just recently been split into having DF that's dealing with the 100 gig signaling portion of the standard. So most of that, what's in the red here, is the DF. So that's 100 gig, most of it over 8 pairs. So that's an octal type architecture. There is also just filling in the gap with a 4-pair 100 gig variant for single mode 2 kilometer. So these are all the DF standards, and they leverage some standards that were published recently. CU, which deals with single mode 100 gig lanes, CK, which deals with electrical, and DB that deals with multimode, all on 100 gig signaling. And this basically, for most of them, is taking the 800 gig MAC rate did not exist till this new standard. So this is basically somewhat lane bonding. It's more complicated than that, but that's really the drive of it. The other big project is now DJ, which is dealing with 200 gig signaling. And there's a huge number of different PMDs there. They're all single mode today. There's not a multi-mode objective in that 200 gig. So I'll come back and touch on that topic again. So in terms of, again, the objectives that are there, so relative to the sort of the subject matter and the title of this presentation, there is 800 gig over 8 pair that is being standardized. That project is going, if anything, ahead of schedule. Its projected completion timeline is 2024. There are announcements already at the last ECOC conference, for example, on 800 gig type solutions as AOC or pluggable transceivers. So that's active and very much in demand. The other use case that's significant is sort of as things move from top of rack to more of an end of row or middle of row type solution. You've got 800 gig switches. You're getting into higher 100 radix and higher data rate switches that are there. they're now, instead of just going to the top of rack, or distributed across multiple racks within a row. So it looks much more like what's always been there in traditional enterprise type networks. It gives you the benefit of structured cabling. And so things can be rolled in, things can be deployed more quickly. So that is another significant use case. And that's the one that tends to lead more towards 100-meter type reach. And in certain networks, specifically a lot of the Chinese hyperscale networks tend to use that architecture. In terms of, again, both DF and DJ, so both the 100 gig and 200 gig signaling, again, there's a lot of different applications for single mode that are being developed. The shortest reach is 500 meters, and that's DR, which is kind of the significant one that overlaps with some of the short reach multimode applications. The others are typically are 2 kilometer or beyond. There's lots of discussions about for the longer reaches at 10 kilometer for 200 gig, if it's okay to continue to use direct detect, or if you need to switch to coherent. So what is more cost effective, what is more technically feasible, becomes a real significant question there. So back to, for multimode VCSELs, for 100 gig PAM4 signaling, so essentially 53 gigabaud in the case of Ethernet. I'll mention fiber channel soon, that is a higher 56 gigabaud PAM4 signaling. There's a series of, again, standards that are available now, 100, 200, and 400 VR and SR, and we'll soon have an 800 gig VR and SR standard defined in DF, as I mentioned. And there's sort of what's also further possible once you have 100 gig signaling. And the first one there, or excuse me, the bullet here, the second bullet here, for 200G VR and SR 4.2. So 4 pairs with 2 wavelengths, so using BiDi. So similar to approach as 400G SR 4.2. This is now 800G using 100 gig signaling that allows you, that's under development. And also going to 1.6 terabyte over 8 pairs, so an SR 8.2. So those 2 things are active. This is not active, but SWDM4, which is another wave division multiplexing technology tied to VCSELs, that allows 4 wavelengths to be utilized. So you could potentially actually have 400G on 1 pair, 800G on 2 pair, and 1.6 on 4 pair. There's nothing active on that, but that technology does exist, and if the customer demand is there, that can be implemented also. So BiDi has actually been around for a while. Just what BiDi does is it puts the receive and transmit on 1 fiber strand. And so basically by transmitting an opposite bidirectional directions, you pick up that 50 gig per fiber pair or 100 gig per pair in this case, which was what happened with 400G SR 4.2. And just a quick note here, in terms of the different fiber types, it's supported on OM3, OM4, and OM5. The reaches vary. OM5 is spec'd to a higher bandwidth, and that 910 takes advantage of that bandwidth that 910 of the transceivers do to give extended reach there. This is something from my colleagues' friends at Broadcom provided of the success that BiDi's had. So BiDi has been very successful in both 40G BiDi and 100G BiDi, and basically utilizing single pair instead of 4 pair. So this has been well deployed. Switch vendors like Cisco, Arista, and Dell, they all have BiDi solutions that are available. And so building on that base is essentially looking at this new Terabit BiDi MSA that leverages that install base of 4 pair architecture to provide 800 gig over the 4 pair. And while there's less, because 400G SR8 is relatively new, it's tended to be used by some of the largest hyperscale companies, but that architecture or cabling plan can now support 1.6 terabyte over an MPO 16. The other one is MPO 12, or sometimes designated as MPO 8. So Terabit BiDi MSA was formed last year. There's now 16 companies that are part of that. The website is provided here. The way it's listed is promoters and contributors. It's actually the original 10 founding companies are on the top. There's 6 additional companies, including OFS, that have now joined this. All 16 will be promoting and contributing and are actively contributing to developing that standard. So there's a lot of work that's going on. It's targeted for 2023. OFC is around the corner, 3 weeks from now. So certainly go to everybody's booth, ask them about what's happening in Terabit by DMSA for these 16 companies, including the OFC booth that'll be there. So, and I'll quickly touch on this, that a little bit of an OFC plug, but we're looking at all our single mode fiber solutions, multi-mode solution, multi-core solutions, hollow core solutions, intelligent sensing, rollable ribbon. So there's a whole list of fiber options there, with multi-mode playing its part on the short reach applications. And in terms of that application, this chart shows that as you're migrating from 10 to 200 gig on one pair and 40 to 400 gig on 4 pair, the same multi-mode cabling infrastructure allows you to support multiple generations. That's significant, especially in the enterprise market, maybe less so in the cloud computing, where they're much faster in changing the speeds and much faster in deploying new cabling plants and architectures. But in the enterprise space, you normally run multiple generations, and lots of customers are still running at 10 gig lanes. That's still a very dominant application. They're migrating to 25, maybe 50, 100. And even though it's 100 gig signaling with this BiDi, you can get 200 gigs per pair. So the same 4-pair cabling system lets you go from 40 gig to 800 gig. If your current usage is today at the lower rates, you're taking advantage of those lower cost transceivers, and you still have future-proof up to 3, 4, 5 generations over the next several years, even decades of looking at that cable plant. So it certainly applies to install base and expanding that, and it can apply to greenfield if you're looking especially at utilizing lower speeds today and migrating all the way up to 800 gig. So the other thing is in terms of connectors of the standards that are out there. MPO12 has been around for a while. It's quite widely deployed. MPO16 less so. This somewhat of a little bit, I've seen some presentations that indicate there isn't a standard. There is a TIA standard. It's what was specified for 400G SR8 and the CM standard. And the BiDi standard will also look at that for SR8.2. So there's a TIA specification that provides the mechanical requirements for a single row MPO16 connector. The IEC standard has been under development for some time, and these are dates that are as of yesterday, the latest dates essentially. So it's been pushed out. So it's 2024. And again, these dates do move over time. They can come in. They often go further out depending on issues that are there. MPO12 is a 2-row MPO12, and that was spec'd in as another option for 400G SR8, and that standard is there with both IEC and TIA specifications. And there's breakout connectors that are being defined in IEC, both the SAC, which is essentially Senko's SN type connector, and the MDC, which is US Connect's MDC type connector. So there's been some hiccups recently, but those projects are back on moving, and with projected completion dates by August of this year is the target dates currently. The other thing of note here is that's not a specific connector, but the performance specification. Multimode has always been, from a return loss perspective, a grade 2N, which is greater than 20 dB. So this new standard, this new version of the standard, which actually is set to be published this month, will specify a 1N, which is tied to mechanically an angled connector type specification mechanically, so that you have greater than 40 dB return loss performance. So these are kind of the most relevant IC and TI connector specs for parallel multimode PMDs. In terms of some of the market projections, so this is CRU data that's on the left here that shows that multimode continues to be deployed globally. If you drill down on it, the biggest growth is forecasted in China. That is the largest market there. EMEA's actually had some flattening. Europe certainly the Ukraine war, some of the effects of COVID economically have flattened some of the demand there on both single mode and multimode. And in North America, it is also flattening. If you look at Burroughs data, it actually even shows a decline. So people are picking single mode more than multimode. But again, in the case of single mode, that data covers all reaches, much longer reaches, not just short reach applications where there is an overlap of multimode, but reaches up 2 kilometers and beyond. So that's captured in the multimode. Light counting data shows essentially both multimode and single mode transceivers. This is from 25 gig to 100 gig transceivers. And what you can see is steadily the single mode transceivers are growing more and more. But multimode continues to grow also in these forecasts. So it's not that multimode transceivers are disappearing. They're still very active. And actually, if you look at the actual absolute volume, it's grown dramatically over the years, just not as fast as single mode type transceivers. So again, some more light counting data in terms of both single mode and multimode transmission shipments and different data rates. And this is spanning from 10 to 100. And the chart on top, as I mentioned, is a multimode 10 gig. So if you look at it, even now, there's lots of 10 gig transceivers that are shipping. This is what's in a lot of enterprise customer networks. It will go down, but even over the next several years, it's still a significant volume. It's the third most popular transceiver type as projected by light counting. If you look at the one that's growing dramatically is 100G. So this is a wide variety, DR, FR, LR, the whole range of single mode variants for lots of reaches. But there's also quite a bit of 100 gig multi-mode that's there. So both of them continue to grow for a lot of enterprise customer needs, but not just today, but probably for the next 5 years. That continues to be the case. Okay, next chart. And so if you look at it from 100 to 400, again, you see that overlap with the 200. The solid lines are multi-mode. The dashed lines are single mode. Again, single mode, more PMD types, more reaches, certainly more higher volumes. But multi-mode stays healthy going forward also. So that's sort of the projections there. I'm going to switch gears a little bit to fiber channel. As I mentioned, fiber channel has been for multiple generations, has both a multi-mode variant and a single mode variant. So the multi-mode is SW, it's shorter wavelength essentially. And that one has steadily, what most customers today are using are 16 and 32. 64 has begun to ship. We are in the process of completing the 128 gig fiber channel. I put a date of 2023 that's gone through all the sort of reviews. It's in the publication process that can take a couple of months or more. So certainly by the middle of this year, that standard will become final and available. It's essentially tied to 100 gig signaling. Fiber channel uses a higher data rate. So it's 112 gigs as opposed to Ethernet, which is 106. So 56 gigabaud PAM4. Is the optical modulation there. So a project that is kicked off, and it's on the chart here. I didn't have this in my October presentation. Is we now have an active project on 256 gig FCPI 9 project. Exactly what that will be, I put a couple of question marks there in terms of the date, and will it be potentially a 200 gig VCSEL if that's available, technically and commercially? Will it be a BiDi? Or will it be single mode only? Those are still being debated, and then that is still an open question. But it's certainly on the map. There are parallel solutions in fiber channel, but they're really not as widely deployed as they are in Ethernet. You don't have the switch to server breakout type architectures as much in fiber channel. So again, this is from the FCIA website in terms of what's projected. 128 was supposed to be technically complete by 2022, and that in fact happened. The publication will happen this year, and there's expected deployment in 2024 timeframe. So again, if you look at all of these things, these are the SW or the multi-mode standards. It's about 90% of fiber channel and enterprise storage area network that's continued to be well utilized. The next one is, again, this question of do we do 256. If the project has been kicked off in December 2020, Will it be 2025? Will it be longer? We don't know. The project's just started. The one thing I would say is that if you hopefully attend IWCS this fall, I hope everybody does that. I think we'll have more information then. If we have a webinar a year from now, I think there'll be more clarity on that topic, or at least that's the expectation. This captures, again, the range of different multimode VCSEL Ethernet links that are 100, 200, 400, 800, and 1.6. So this sort of summarizes that there's continued life in multimode with overlap with single mode, even in short reaches today. But there's lots of applications that are either out there that are commercially deployed and successful, or are under development currently in terms of the different reaches that are there. Including this Terabit BiDi MSA. I actually, just to keep the table, I was trying to squeeze everything in. There is a VR variant to this also, but I listed the SR. These are still question marks until the spec is written. Right now, potentially it's around 45 meters on 3, 70 meters on 4, and 100 meters on 5. So, I sort of wanted to do this a little by effect, which is single mode Ethernet based links for 100, 200, 400, 800, 1.6, up to 100 meter reach. So if you're looking at short reach. So it's blank purposefully because there are no standards like that. There haven't been standards like that. When we started the DB project, it was not targeted to multimode. It was targeted just to short reach, and including single mode and multimode, and there were contributions made in both areas. That group ended up at multimode being the right application there. So there are, again, the reaches that are there for single mode are 500 meter, 2 kilometer, 6 kilometer, 10 kilometer, 40 kilometers. There's actually 80 kilometer standard that's actively being worked. So there's lots and lots of single mode PMDs, and that 500 meter, the DR one, certainly becomes a viable short reach option that many customers are picking. If in fact your data rate needs are today 100 gig migrating to 200 gig. If your data rates today are 10, 25, 50, and you're migrating over time, multimode still gives you that value proposition. And even the largest hyperscale companies, there's always somewhat of a, sometimes a misstatement that, hey, the cloud companies are all switching to single mode. If you look at for their short reach applications, so for within the rack, they'll often use direct attached copper. For between, up to 30 meters and sometimes as much as 100 meters, they'll use AOCs. And those are also VCSEL multimode type links. They're closed links where you control the transceiver on both ends, so it's easier to get performance from there. And as I mentioned on both the DB standard, what's happening in the Terabit BiDi, a lot of Google, Alibaba, Tencent, a lot of the hyperscale companies are looking at those VCSEL multimode links as their lowest cost, lowest power solution for very short reaches. So again, so for that short reach, it's that low transceiver cost. That gap has narrowed or flattened if you get to a 100 gig DR. We'll see where 100 gig SR as it's being introduced ends up, but those are in parity cost-wise in many cases. But if you look at in terms of power, if you're using 100 gig SR4, for example, very widely utilized in enterprises, will continue to be utilized. That's 2.5 watts versus 3.5 watts for the various PSM4, CWDM4, LR1, DR type single mode applications. So both in terms of initial cost and operating cost over the longer run, there's still some significant advantages for multimode type transceivers. And it's always tended to have this advantage of higher usability, more resilient to contaminations, a lower cost structure from a connectivity perspective. So again, just where we are with multimode and single mode. Again, I want to give credit and thanks to my friends at Light Counting that shows a deployment across 400, 800, and even 1.6 terabyte, and not for the BiDi version, but 1/16 pairs. And there's always a multimode line within these charts that projects growth there. Again, more so in single mode, because single mode covers much more range of reaches, much more longer reaches, overlap between the 500-meter reaches and the 100 meters in the case of multimode. But it's very much there for each of them. In the case of 400 gig, the second fastest growth is projected for 400G SR8, the project that was published in 2020 and has been quite successful. The 400G SR 4.2 was not as initially widely deployed, but is being deployed currently. There is an 800G VR 50-meter that's forecast. It's shown as SR, but it's a 50-meter version of that. And as I said, even a projection for 1.6 over 16 pairs, 100 gig single wavelength type solutions. So an eye chart here, lots of just sort of capturing some of the literature that's there. One of my co-authors, Yi-Sun, put this together. She keeps an eye on what's happening in sort of the latest, whether it's in academic publications or at OFC or other forums. So VCSELs continue to be pushed. And, having worked on the projects that were 50 gig lanes and 100 gig lanes, when each of these projects is started, there's always a question if there's multimode, we're done with multimode. There isn't another generation left, but that certainly wasn't the case with 50 gig lanes and 100 gig lanes. And we'll see where we go with 200 gig lanes. And as I said, I think in a year from now, we'll have more clarity on this. We'll see what other projects may or may not get started, but technically that's there. But, technical standards is only one facet of this. What really counts is commercially, or do enough customers want those solutions, and what is that market size so that companies can dedicate their resources in those areas. So just to wrap things up here and finish things, so multimode solutions continues to support increased Ethernet and fiber channel rates, up to 100-meter type links, essentially. That's well deployed. And it still tends to be low cost, low power, high usability, short optical solutions, even up to all the way up to 800 gig and 1.6 terabyte with this upcoming Terabit BiDi MSA. But multi-wavelength solutions, in that case, 2 wavelengths, give you sort of more future-proofing in being able to utilize those longer wavelengths, 910 in the case of BiDi. If there is potentially a SWDM4 in the future, that would be 940. And there, fibers like OM5 have an advantage, but OM4 does very well for those solutions also. Multimode, again, is very widely utilized and deployed, and is very successful always for longer reaches. There's solutions for 500-meter solutions, the DR solutions, that can also be viable as short reach solutions, depending on your current application speeds, your network, compatibility, installed base, all of those things matter. And in terms of true 200 gig signaling development, that is an active project in 802.3, 802.3P, 802.3 DJ. It's forecast to be published in 2026, but there's the version 1.0 of that spec is targeted for actually end of this year. So that's aggressive. I'll give a quick plug. It's one of the best chairs in IEEE. John D'Ambrosa leads that group. Mark Noel is the vice chair. There's a terrific team of editors and people there. Kent Lusted, Mark Brown, lots of folks there, some of the industry experts that are driving that forward. It's a very, very challenging project, lots of things to overcome, but I think we'll get there. So with that, Dave, I will entertain questions that may have come up.
Mabud, as always, just an incredible amount of information, very valuable and extremely current for all of us. And I don't know about everyone else, but I'm going to have to watch this webinar again a few times to digest all of the individual components.
Webinars all the time. It's the best thing to do on the weekend.
No, Mabud, thank you very much for a great presentation. I invite anyone to ask questions. I have not seen any questions written in the chat. Again, there's so much content here. I can probably understand, where to go to first. But does anyone have any questions here before we wrap things up? And again, if you do, enter it in the chat. While we're waiting to see if any come in, I do want to apologize for our friends at Microsoft who have taken upon themselves to just update things without telling any of us how to remodify everything to our own liking. I saw a couple of people comment that they could not see the slides. I'm not sure what settings locally that have to be adjusted, but I'm sure you'll figure that out. But most of us could see the slides, and most of us could see Mabud. So I think we're in in good shape. We did record it, so again, you can watch the webinar again. Question, Mabud, why multimode transceiver consumes less power than single mode?
So that's always been inherently the advantage of VCSELs. VCSELs are low power devices. They were conceived. I actually had the very good fortune to work with one of the co-inventors of the VCSEL, Jack Jewell, earlier in my career. So that work, VCSELs were always designed as sensor type technologies. That's why you see them in your 3D sensing. That's why you see them in LiDAR. Single mode has always been tuned towards longer reach and therefore longer power. So that's been the difference there. But again, that as you go to the higher data rates, that gap is narrowing. And that's where I think it's important to go to IWCS, to listen to the webinars, to talk to your trusted vendors in the industry to see which mix makes the best sense. Because most of the companies that I listed, for example, on the Terabit by MSA, they utilize both. They make great transceivers, great fiber solution, great switches, great servers that serve both of those. So it's that mix. But VCSELs, it's interesting how certain technologies endure, and VCSELs are up there. Prior to doing optical, I used to deal with twisted pair, copper twisted pair. Alexander Graham Bell invented twisted pairs. So certain technologies have very, very long lives. We're going through this, in my opinion. I'll give you an analogy with, I just had this where my lease came up. My car sat in the garage for 3 years during COVID, and it was time to decide what to do. And do you buy an electric car or do you stick with an internal combustion engine? Another technology that's 100+ years of remarkable progress and continuity. So I stuck with internal combustion engine for this cycle, and I think most of us will. But over the next 5-10 years, we'll all make that switch. And I do think multimode potentially, I didn't cover that, could go down into where copper is today. Direct attached copper will be down to 1 meter with 200 gig. And over time, it may be that that's what's there. There's an automotive standard, 802.3CZ, which is about to be published, that is putting OM3, high temperature OM3, 980 pixels for automotive applications. So we've got automotive networks that are hundreds of nodes in the car as things go autonomous, as things go electric. So I think that's long answer, but that's sort of inherent to VCSELs, has been that low power, high, easy testability, tremendous reliability. If you look at the billions of VCSELs that have shipped, it's quite remarkable.
Yeah, excellent perspective. How do you calculate the reach distance for VCSEL-MMF systems?
So that's so our friends who are affiliated with Broadcom and formerly Finisar Coherent and Lumentum, a lot of those companies, what you're doing is you're closing that optical link. You're looking at the eye closure. You're looking that you can meet those requirements as you're going forward. So based on the performance of the VCSEL, the bandwidth of the VCSEL, based on the performance of the fiber, that combination of that, it used to be a simple spreadsheet years ago that we all looked at. It's gotten a lot more complicated with PAM4, with TDQ type measurements. But there are a lot of experts there, including in the fiber community. Jose Castro is one of the leading experts, in my opinion, from the fiber side, who deals with a lot of this work. So you have to develop some fairly complex models to show that, and then you have to make measurements and see, did your simulated models actually live up to reality? That's based on making things, scaling things up, and production yields and things like that.
Excellent. So again, Mabud, we thank you so much for this excellent and most interesting presentation. A lot of claps I've been seeing, and and thank yous from Sweden, from Asia. So again, thank you very much. You can see on the screen now Mabud's contact points. IWCS does not share the slides from the presentations, but you can reach out directly to Mabud and he can discuss and share, if appropriate, with you directly. So please note the contact points. And also remember that each of these webinar series events are recorded and will be archived on our website. And again, thank you for the plug by Mabud. Please join us in September in Orlando, Florida. For those of you who haven't been to Disney in many years due to COVID and everything else, we hope that you can join us and have some fun as well. But please also take a moment to consider entering an abstract for our technical symposium on your perspectives in technology from your companies. Talk to your supply chain partners, your suppliers, your customers, and also, again, enhance the conversation and information that we can all receive together during the IWCS Technical Symposium in September. The webinar series, yep, Mabud.
I just again wanted to thank you again for what you individually do. The folks in IWCS, Becky, Michelle, do an outstanding job. It was terrific to be in Providence, Rhode Island last fall after a couple of years of not seeing folks. So I think that was wonderful. It took some courage to say, hey, it's going to be in person only, but I think it was tremendously successful, and I'm sure Orlando will be that way too.
Well, I think most of us like the in-person only thing. I mean, these webinars are helpful, and but
it's a hybrid world. Really hybrid. We do both.
Yeah. So the
just
the
like
networking,
multimode, you can have more than one choice. It's good.
Well, anyway, we would appreciate seeing you in Orlando in September with all the networking possibilities. But just so you know, also our next webinar is scheduled for March 17th, which is the third Friday of the month, which is how we try to be consistent on these webinars, 10:30 a.m. Eastern time. So each of you will receive an announcement, and we hope that you'll share these announcements with your colleagues so that they can join and register as well. So again, please enter your technical papers as technical abstracts so that we can review them in April and select your paper to present in Orlando. Before we conclude, I do want to recognize the important contributions by our IWCS partner level sponsors. They contribute greatly to the success of our Cable and Connectivity Industry Forum. Without their strong leadership, like OFS, and their generosity, we would not be able to bring these important technical innovations and information to you, as well as our global community. So thank you to OFS and these leading suppliers for in our industry for your support. For over 71 years now, IWCS has been the recognized leader in showcasing new technologies for products, processes, applications. So our 72nd annual Cable and Connectivity Forum will be in person on Sunday through Wednesday, September 17th through 20th in the Gaylord Palms Resort and Convention Center in Orlando. Watch your inbox, social media, as well as our website to learn more as the exciting information becomes available. That will be iwcs.org. So again, thank you for participating in today's event, and have a great weekend. And Mabud, you're a rock star. Thank you.
Thanks. Have a great weekend.
Take care.